This is probably chapter 6, chapter 7 of physics, okay? Now let's quickly take a look at pressure. In our previous class, we looked at momentum. We've done moment, we've done momentum, okay? We've done Hooke's laws, we've done forces, and so on and so forth. Okay, we've done motions, and so on and so forth, graphs of motions, and so on and so forth. Now let's quickly take a look at pressure. Now what's pressure? Pressure is a scalar quantity and is defined as the force per unit area. So pressure is technically defined as force per unit area. Okay, we say pressure is the force acting on an object per the area that the force is exerting on. Okay, the force per the area. So pressure is equals to F over A, force per unit area. Now, where do this force come from? You know, objects, when they start to vibrate or they start to move, when they hit a wall or they hit or they collide with themselves, that movement, you know, must come from a force. A force will cause an object to move, and a force will cause a moving object to stop. So that force and the particular area the particle hits is known as pressure. So force per unit area we define as a pressure. Pressure is technically defined as force per unit area. So before we digress further, we talk about pressure properly. Let's quickly listen to this our tutorial and get a grip of what pressure attains. Is that okay?
This video is about pressure that occurs between solids in contact with each other. Pressure is applied between two solid objects whose surfaces are in contact with each other. Pressure is defined as the force per unit area, though it is the ratio of force applied over a certain area. It is calculated using the equation pressure in pascals is equal to force in newtons divided by area in meters squared. If the same force is applied over a smaller area, then the pressure will be higher. For example, the same person with the same weight stands on the grass in a trainer and applies less pressure to the grass than if they were standing in a high heel. This is because their weight is distributed over a bigger area. People often sink into the ground when wearing high heels, but not in trainers. Don't get confused. When the area is smaller, then a greater pressure is applied. It is common to be asked about large or small amounts of pressure applied to a situation. Here, a child lies down in the snow on an incline and does not move down the incline. In the same location, he then sits on his sled. Explain why he now moves down the hill for 3 marks. The boy does not move lying down because he sinks into the snow. He moves in the sled because he sinks only a little bit into the snow. The surface area of the sled is greater than the surface area of the boy's body for 1 mark. So the pressure applied by the sled on the snow is less for the 2nd mark. He does not sink into the snow or is able to move for the 3rd mark. You need to know how to calculate pressure in different situations too. Here, a cardboard box with a mass of 500 grams and dimensions of 100 centimeters by 20 centimeters by 30 centimeters is placed on a table. Calculate the pressure exerted by the box on the table for 4 marks. Obtain the correct value for the weight of the box. Convert the mass from grams into kilograms so it is easier to calculate the force. There are 1,000 grams in 1 kilogram, so 500 grams is equal to 500 divided by 1,000, which is equal to 0.5 kilograms. Then calculate the weight of the box, which is equal to the force applied to the table. Weight is equal to mass times gravity from Newton's second law, which equals 0.5 times 9.8, which is equal to 4.9 newtons for 1 mark. Here we assume that the acceleration of freefall g is equal to 9.8 meters per second squared, unless otherwise specified in your exam question. Use the information given to determine the surface area in contact with the table. Looking at the image and the dimensions, the surface area in contact with the table must be 20 centimeters by 30 centimeters. Convert the area into meters squared to give pressure in pascals. It is easiest to convert each length into meters. So the area is equal to 0.2 meters times 0.3 meters, which is equal to 0.06 meters squared for 1 mark. Substitute these values into the equation for pressure. Pressure is equal to 4.9 divided by 0.06 for 1 mark. Calculate the pressure. Pressure is equal to 81.66 pascals, which is equal to 82 pascals to 2 significant figures for 1 mark. Remember, pressure is measured in pascals, which are newtons per meter squared, and not newtons per centimeter squared. Don't be tempted to use the total surface area or volume as the contact area. In summary, pressure is applied between 2 solid objects in contact with each other. Examples include a shoe in contact with the floor or a box in contact with a table. Pressure is defined as the force per unit area. It is calculated using the equation pressure in pascals is equal to force in newtons divided by area in meters squared. Pascals are the equivalent of newtons per meter squared. So make sure you convert mass to weight in newton and dimensions into meters before calculating area. For the same force applied, increasing the contact surface area reduces the pressure, and decreasing the contact surface area increases the pressure. Don't forget to check out all our other fantastic revision resources here at Save My...
Okay, now we've seen the tutorial on pressure. So the basic things have been explained. Pressure is force per unit area. It happens between 2 surfaces that are in contact. Okay, a force pushes something against something. So when something hits a wall, when a car hits another car, there's pressure exerted. When molecules hit one another, okay, they exert force, or they hit the walls of a container, they exert a force. So it must be like 2 things that are in contact with each other. Now we say that pressure is force in Newt. You know, the unit of force is Newt. Is force in Newt over area in meters squared. The unit of area is meters squared. Okay. Now, which gives us the unit of pressure to be Newt per meter squared. So in case you don't know, you can derive the units also. So we can have the unit of pressure to be Newt per meter squared. This Newt per meter squared is what we call Pascal. Okay, this was according to the scientists that they first discovered pressure. So 1 Pascal equals to 1 Newt per meter squared. So the unit of pressure is Pascal. So Pascal, summarily we write as PA. Okay, the symbol for Pascal, PA. So 1 Pascal is equals to 1 Newt per meter squared, equal to 1 Newt per meter squared. Is that okay? So whether you write Pascal or Newt per meter squared, it's the same thing, but not Newt per centimeter squared. So when you have centimeter for area, you convert that to meter in order to get the approximate unit of pressure. And that is stated here. Pressure is measured in Pascal. Okay, this is the unit of pressure. Pressures are measured in the Pascal. Okay, now let's move on. Pressure is measured in Pascal, and we already say 1 Pascal is equal to Newt per meter squared. Now the formula is there as related as shown. Pressure is force over area. This formula. This is what we use for calculating pressure in solids. Okay, we have another formula for calculating pressure in liquid, which will be part 2 of this video. Okay, part 1 of this video is talking about pressure in solid, like your shoe. If you wear the sneaker shoes, the pressure exerted on the ground is lesser than the pressure exerted by high heel shoes from the ladies. Okay, because pressure is inversely proportional to area. So pressure is directly proportional to force. So if you want a greater pressure, you increase the force, you increase the amount of force, because pressure is directly proportional to force. So you increase the amount of force, but you decrease the area. If you want a bigger pressure, you make the area smaller. The smaller the area, the bigger the pressure. The bigger the area, the smaller the pressure. That's why the pressure exerted by a sneaker shoe is smaller than pressure exerted by high heel. You know, high heel has a pointed toe. So that can easily sink into the ground. if you take a very sharp knife, if it cuts you, it will exert a great pressure on your body and goes in, and blood will start to ooze out. If you take a knife that is not sharp, even if it hits you, it may not cut you because the pressure is smaller. So the tiny tip of a very sharp knife has a small surface area, so it will exert a greater pressure when it touched us. So here is the triangular formula for pressure. So if we put it in triangular form, pressure is force over area. If you want area, area is force over pressure. If you want force, because there are some cases where we have to make one the subject of the formula. If you want force and the pressure is given, you say force is pressure multiplied by area. Force is pressure. If you want force, force is pressure multiplied by area. If you want area, there are some cases you need to calculate the area, but the pressure is given and the force is given. You say area is force over pressure. So you need to know this. It's very, very important. Okay, we move on to the applications or examples of pressure. Let's take a look at examples of application of pressure. Okay, the first one is a tractor. Tractors have large tires. They have very large tires. This spread the weight or the force of the tractor over a large area. So the pressure they exert is reduced. This reduces the pressure which prevents the heavy tractor from sinking to the mud. If not the large tire, the larger the surface area in contact, the object is in contact with the ground, the smaller the pressure. If the tire were a small tire, the large truck or large tractor will sink it to the ground. Okay, now let's take a look at drawing pin. Okay, let's take a look at drawing a pin. You see a pin, the tip of the pin has a small surface area. The head of it has a very large surface area. So here, if you exert your hand here, you don't feel pain. If you come and take the pin and exert your hand and the tip of the pin, you're going to feel a lot of pain because there's greater pressure. There's greater pressure from that. If you take your pen, like your writing pen, from the top, if you use it to touch your hand, the pressure is not as great as you use the tip where you write on the book to touch your hand. It will be greater pressure. So what it then means is that the smaller the area, the smaller the surface area, the greater the pressure. So when you see, because you can see the case of high heel with small surface area, so the pressure here is high. But a sneaker shoes, we have a low pressure because it has a wider surface area touching the ground. Is that okay? So now we move on. That's it. The weight from the heel shoe is spread over a smaller area. So when you have a smaller area, therefore you have a larger pressure. You have a higher pressure. And this one, the weight of the sneaker shoe is spread on a larger surface area. Therefore, the pressure will be low. Because they are inversely proportional. Pressure is inversely proportional to area. Inverse. Okay, since they are inversely proportional, the bigger the pressure, the smaller the area. Or the bigger the area, the smaller the pressure. That's it. That's just the point. Now let's move on. Let's take a look at this example. The diagram below shows that part of the lift machine used to move the platform up or down. Okay, let's take a look at it. Okay, you can see this is hydraulic system. This is used in hydraulic system. Is that okay? The diagram below shows part of the lift machine used to move the platform up and down. Now let's take it. This is showing the movement. The guy is standing on this platform, and we can see the liquid is flowing here. We have a pump here. We have a liquid flowing here, and you can see this cross-sectional area is smaller than any area on this side. The cross-sectional area is small. Here is small. So we say the cross-sectional area of the pistol here is 0.0273. 0.0273. So it's smaller than the area on the other side, meter square. Okay, the value is in standard form. I just put it in a normal form. This standard form is 0.0273. Okay, so this is the area here, and you can see the area here is way larger. So the smaller the area, the greater the pressure. So this liquid is able to exert a great pressure to move this thing up, to move this guy on this platform up. okay, because the area is smaller. If this side was wider, then the distribution in the hydraulic system will not produce a greater pressure to move this guy up. Will not produce a greater pressure. So the smaller the area, the bigger the pressure. Now let's take a look at this question. Here is a question for calculation. The pump creates a pressure in the liquid of this. So we'll be given a pressure of 528,000 Pascal to move the platform upward. Calculate the force that the liquid applies in the piston. Calculate the force. You know the area has been given to us, right? Now we need to calculate the force. We know the area, we know the pressure. Pressure is given as 528. If I want to change to number, okay, 5 to not in standard form, then 0, 0. This is what this one means. This is what this one means, Pascal. Okay, 528,000 Pascal. That's the pressure that the pump creates. And then the area with which the liquid is exerting on to move the pump up, to move the platform up, is the area is given as 0.0273. 0.0273. 0.0273. Now we are asked to calculate the force. Now we're going to make force the subject. Here, pressure is force over area. Pressure is force over area. So we're going to make the force the subject of formula. To do that, we have to cross multiply. We have to cross multiply this times this, right? We cross multiply these two. So force is technically Pascal, or pressure times area. Force will be the pressure times area. So once we know this, and then we substitute, and then we can calculate our force. So force is equal to our pressure, which is 528,000 Pascal, 528,000 Pascal, multiplied by the area. What's the value of the area? The value of the area is 0.0273. 0.0273. So let's see what we get if we multiply this. The force in Newton. Remember, force will be in Newton. So our force is equal to what? Our force is equal to, what's our force? 228,000 times 0.0273, we get 40,414. We get 40,414. Okay, 40,440 point, probably 0.4, right? 440 point. So we can approximate to the nearest 100. We get 40,400 Newton. Or we leave it like this, okay? Newton. You must put the unit. You don't put the unit in physics. When you calculate anything, it will be 40,400 oranges. So we will know it's force you calculated. You must put the unit to define what it is, okay? 40,440.4, which to the nearest 100, it will become 40,400, like I said earlier, or to 3 significant figure. Okay, so that's the basis of pressure. These are just the same thing. Force is a scalar quantity, and pressure, not force. Force is a vector. Pressure is a scalar quantity. Force active per unit area. Okay, and we say the unit is Pascal, and scalar quantity. Yeah, pressure is a scalar quantity. Okay, so we say it's force active per unit area, and we say 1 Pascal is equals to 1 Newton per meter square. And then let's take a look at this. When object acts on, let's say you have a dimension like this, a cuboid like this, standing on the ground. Okay, we have one rectangular one, and we have one vertical one standing like this, and we have the weight of the object. Okay, if you look at these two, they are same, but they are standing. We are using different faces to stand on the ground. So the one with the bigger surface area will get a smaller pressure. Okay, both of their weight is same because it's the same object. Both of their weight is same. So, but we are not standing them on the same face. One you're standing this way, the other one you're standing like this, okay? One is standing, you can see standing right, upright. The other one is standing flat on the ground. So to calculate the pressure, we have to calculate the area first of the face that is touching the ground. So the area is 6 meters squared. Area of the face that is touching the ground is this length of this face of this rectangle times the width of this rectangle. So we say 3 times 2, which is 6. So the area of the face touching the ground is 3 times 2, which is 6 meters squared. Now that we know the area, and we know the weight. Weight is same as force, okay? Don't get it twisted. Weight is same as force, 24 newton. You can see the unit is the same. So now pressure, to calculate pressure, we're only going to say pressure equals to force over area, right? We only say pressure is force over area. Look at it. Pressure is force. The force is the same as the weight, which is 24 divided by 6. We get 4 Pascal. 4 Pascal. Kilopascal means 1,000 Pascal. 1,000 Pascal is equal to 1 kilopascal. But this is just 4 Pascal. Is that okay? Now you can see the pressure of this one. Now let's see when it's standing, when it's face down, rectangularly. Now we calculate the area here. So you can see the area here. Here will be the length. For this face, here will be the width. So we say length times width is 12. 3 times 4 is 12. We get the area of the face that is on the ground. Now the pressure will be the 24, which is the weight of the object. You know, pressure is force over area. Pressure is always what? Pressure is force over area, or weight over area. Force over area or weight over area. So in that sense, we say the weight is 24, which is given to us here. Both of them, they have same weight. We say 24 divided by the area of this face that is touching the ground. So when you divide by 12, you get 2 Pascal. Now what we see here is that the pressure here is only 2 Pascal. Why the pressure here is, so the area here was smaller, the pressure was bigger. Why the area here was bigger, the pressure was smaller. So that's what we're trying to let you know, that the bigger the surface area, the smaller the pressure. The bigger the surface area, the smaller the pressure. This formula has been given, so we hope you take note. Pressure is force over area, and force can be derived. You can derive this one because this is force is pressure. You know, force is PA, right? Force is PA equal to PA. That's Pascal times area. That's for force. Force is Pascal times area. Okay, if that is true, I say Pascal, pressure, the unit is the same anyway. The unit of pressure is Pascal. So force is pressure times area. So if that is true, we know the formula for pressure. We can replace it. Right? We can replace the formula for pressure. So we can simply say force is equals to, instead of writing pressure, I can write force also. I can write force. Maybe to differentiate the 2F, make this one small f. Force over area in place of, which is pressure, then times area, times the big area. I use big A to differentiate the other one. Okay, so you can see you can do a lot of assumptions and calculations and so on and so forth. So here you have A over A, right? This one actually means A over A. So you can rewrite it and say F equals to F times A over A, big A over small a. Big A over small a. Okay? So there are many things that we can play here. Now this is the hydraulics. If you ever gone to a mechanic workshop, you see that they have hydraulic system for lifting car up so that they can walk under the car. In those days, mechanics used to sleep on the ground to try and walk under the car, right? But nowadays we have hydraulic system to raise the car up. We have a platform which we've explained. There's a liquid here, the hydraulic system. The area here, if we wanted to be able to lift this, we make the area here smaller so that greater pressure will result to push this platform up. Is that okay? So that's the system that is created for this. So with this we come to the end of our part 1, and we're going to take part 2, pressure in liquid and pressure instrument for measuring pressure, and so on and so forth. Thank you for joining us.